we now have over 70,000 vehicles on Indian roads that are using our BMS. And we've collected a tremendous amount of data to help not only collect primary state estimation, but also use the data with opportunistic recalibration algorithms to continuously improve the accuracy on Indian roads. Once you have a cell, you essentially put those cells into modules. Those modules typically make their way into a pack, and then packs typically go inside of systems, right? So that's sort of the sequence. When you start building battery modules or battery packs, you need a layer of management for those batteries so that you can not only tap into the data that we are logging at every single cell, but also build a layer of safety at that pack level in a way that when these batteries are charging or discharging, there are no fatal incidents that happen, right? And so that's essentially the layer that we typically call battery management, simply put, very good name. And for this purpose, there's essentially a advanced electronics controller that is introduced inside of a battery pack, which is called a battery management system. So that's essentially what a BMS is, right? So that's the first layer of context. So far, the history of the BMS really starts with something called a PCM, or a protection circuit module, which essentially just took care of safety. And so this was when we were building power banks and mobile phones and small battery packs of 100 grams and 200 grams, where you wanted to make sure that in the case that something bad happens, you want something like a fuse, right? Just like you have a fuse that will sort of disconnect and prevent the battery from exploding or any harmful situation. Now, as we went from hundreds of grams to hundreds of kgs, right? Clearly, you need better technology and you need more layers of safety. Because the risk levels also increase. And so naturally, the electronics have shifted from PCMs to what we call today BMSs. The big difference between PCMs, which are protection circuits, and battery management systems is the fact that battery management systems typically have a microcontroller, which means that they're not just a dumb fuse, so to say, but they also have a brain. And what does the brain allow them to do? It allows the electronics to do things like estimate the current state of charge of the battery, estimate the current state of health, and so on, state of power as well. So what does that mean? What does state of charge, state of health mean? Whenever you put your phone on charging, your laptop on charging, you see a certain percentage, right? 10% left, 20% left, 30% left in your battery. That is essentially the output of a battery management system that exists inside of your phone or your laptop. So what it's doing is that it's taking the raw current, voltage, temperature, converting that into a state of charge, which is basically giving you a percentage. Now, if you can imagine, sometimes on your phone, let's say, even if you buy an iPhone, you might buy it and then 2 years later, it might show you 75% and suddenly drop down to 65% or 68%, right? Nobody likes that. On your phone or your laptop, it's not a big deal. You can just put it on charging and that's fine. So you're not happy about it, but it's not a big problem. But when you move into bigger batteries, like say electric vehicles, right? So imagine you're driving your car, and it says that you can go 25 kilometers, and you say, okay, that means I can drive until home, so no problem, you're driving. And suddenly halfway it tells you, hey, by the way, actually I was wrong. So you just have 5 kilometers left, right? And now you have to sort of stop on the side and find one of Maxon's chargers and figure out how you're going to charge this vehicle, right? Which is why it's extremely important that you have a highly accurate state of charge, state of health estimator algorithm that is running inside of big batteries that are going inside of electric vehicles. And so that's essentially the start of what we've been doing at ION, and also the product that we've been sort of selling in the market. So we've been fortunate, like in the last 4.5 years, we now have over 70,000 vehicles on Indian roads that are using our BMS. And we've collected a tremendous amount of data to help not only collect primary state estimation, but also use the data with opportunistic recalibration algorithms to continuously improve the accuracy on Indian roads. Right, India is very different from Germany, for example, or the US when you want to do state estimation or range estimation. Again, similar to once you understand the state of the battery, only then you can say how many kilometers can you drive, right? So that is the conversion of state of charge into distance to empty, right? So how much distance can you travel before it is empty? So all of these estimations have to happen in a highly accurate way. And these are typically the responsibilities of a battery management system. We've been fortunate, like I said, to be able to collect the data and improve the accuracy of this over time. But there is a layer above that, which is not just at the local battery management, but how can we bring the data from these vehicles to the cloud and then leverage the data not only from one vehicle, but from the entire class, the entire set of vehicles, and try and improve at the core, at the fundamental level, the state estimation algorithms, and also run co-optimization algorithms. For example, if you are owning and operating a fleet, imagine you're an Ola or an Uber, and you want to collect the data from all of these vehicles and come up with an algorithm to say, how can I manage my charging speed and my charger locations to ensure the highest fleet uptime during peak requirements, right? So these are the types of challenges that you can solve using software if you have that connectivity.